All right, now we're ready. All right, so we're going to be talking today about the focus of a parabola. This is kind of a different way of looking at a parabola compared to what we've done before. I like to think of this as the more like geometry way of thinking about it. And that's not like, doesn't mean we're going to be doing proofs and things like that, but it's more of like the physical characteristics of a parabola and using that to define how it gets put together. Yeah. All right, so I'm going to draw you a little picture to start with here. And this is going to help us redefine a parabola using what's called the focus directrix definition. Okay, so there are going to be some things on here that maybe, like, why are you putting that on there? But I'm going to use that picture to help me explain what I'm doing later. So let's say we've just got some parabola. All right, and this point down at the bottom, this one happens to open up, but the one at the bottom here then is called what?
Vertex.
That's a vertex. Okay, vertex is still going to be in play. Still going to use that. Okay, and then there's going to be this other point, maybe like up here somewhere. It's called the focus of the parabola. It's a point that the parabola wraps around but doesn't actually like go through. Okay, if the focus is directly above the vertex, you guys remember yesterday, or not yesterday, the day before, we were talking about the axis or line of symmetry, right? Or axis of symmetry. It's called both things. So the focus then, because of where it is, would sit right on that thing as well. Okay, so that imaginary line of reflection or line of symmetry, LOS. Okay, it's right on that. And then there's a line. That's the directrix. And this line sits down here. Okay, so not only do we have this parabola, but we have these two other things that are working with it here. This focus that it wraps around, this directrix, that's this strange line that's sitting underneath it. Okay, now I'm going to use, like I said, I'm going to use this picture to help explain this new definition of a parabola we're going to use today. Okay, so here's what it says. A parabola is a collection of points equidistant from a point which we call the focus and a line which we call the directrix. Okay, so I'll break that down here in just a minute too, okay? Just give you a chance to copy it down. All right, let's chunk this out one little piece at a time, what we just wrote down, okay? So a parabola is a collection of points. Do we all agree with that? Okay, so a parabola, there are a bunch of points that are on the parabola, and it's just all these one after the other, boom, 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 makes a little parabola. Okay, so it's a collection of points that make the curve that are equidistant. What does the word equidistant mean? Equal distance, right? Okay, so they're all the same distance away from two things, the focus and the directrix, okay? So if I were to pick any little point on the curve of the parabola and measured how far away it was from the focus and then measured how far away it was from the directrix, it should always be the same no matter where I pick one, okay? So, for example, let's say I pick a point like right here. Now the way I drew my parabola, this is probably really not going to look to scale at all, but just bear with me. I've got a better picture coming up in a minute. So this point, if I measured its distance to the focus, okay, so it'd be like a straight line, boom, to the focus, okay? However long that is, if I were to also figure out how far away that point was to the directrix, so straight down to a point on the directrix like that, this line segment and this line segment should be the same length. Okay? Not to scale, I get it. I did a bad picture, but they're supposed to be the same distance. Okay? So, that's how we're defining this a little bit differently. Before, it was all just x and y, and there was all those relationships, and we used that just y equals x squared, parent function, and then moved it around and all of that. Well, technically, a parabola can be built by taking these points and figuring out, like if we start with a point as a focus, start with a line as a directrix, and then have all these little points that are this like halfway in between, it'll slowly start to build up this parabola, okay? So I'm going to pause the recording for just a second, and what I'm going to do is I'm going to switch over to a website that has a picture of one of these, like a little animation of this, so you can see it a little bit better. But this is the idea, okay? All right, we're back. So I'm going to draw another picture of a parabola. Now, if we're going to start coming up with equations for these things, we're going to want to put these on the coordinate plane. So that's what I'm going to do next. I'm going to draw the same focus directrix picture, but we're going to put it on a coordinate plane. And we're going to start today with parabolas where the vertex is always at the origin. Okay? Tomorrow we're going to start moving them around, but for today we're going to leave them so that the vertex is right here and the parabola comes off of that. Okay, so if this is the case, we've got the x-axis, we've got the y-axis. Focus would be somewhere up here, and directrix somewhere down here. Oh yeah, and vertex here. Okay, so we need to know, if we're going to make an equation, we need to know what are the coordinates of the focus. Remember, the focus is just a point. So what are the coordinates of the focus, and then what is the equation of the directrix? If we know those two things, we can make our equation. Okay? So now we're just going to be generic now, okay? Because the distance between the vertex and the focus could be 2, it could be 5, it could be 1/2, or whatever. So for now, we're going to just call it P. We're just going to use the letter P. Okay? I don't know why the letter P is the accepted letter to use for this sort of thing, so don't ask me. But it is. Now, if the distance from V to F is P, then what is the distance from V down to the directrix? Yeah, P, right. So they're the same, right? So both of those are going to be P. And then our equation that we make for this is going to have P in it. So it's going to be y equals 1 over 4P x squared. Now, why is it 4P? Sort of. It's called the focal width, but you know what? I'm not going to get into it right now. I could show you a proof of this, but I assume that you guys probably didn't want to mess with that. If you're really interested, your textbook does have it in there, so you can follow it and see. It's at the beginning of section 2.3. You can go look right through there. They do a really good job of explaining why they're doing what they're doing and how the equation works out to this. But I'm not going to bother you with that, okay? I just think we need to be more concerned with, if this is the equation we know we need to use, how can we use it the right way, okay? Question?
Why is it 1? The reason why it's 1 4 p.
Again, same thing that I was just explaining, that there's a proof of y. It's in your book. If you want to see it, you can, but I'm not going to mess with it. Okay, so all you guys need to know is that whatever the length of p is, you just need to take whatever that number is and plug it in there and you're done. Okay? Now, if this equation, or if this parabola were to, let's say, open down instead of up, what do you suppose is the only difference to the equation then? It would be negative 1 over 4p x squared. Okay? Same thing as before. If we have a parabola, if we have any function and we want to reflect it down, we just make it negative. Okay? So you can do those kind of parabolas too. You just have to make sure that it's negative when you do it. Yeah. It is. Yeah. I mean, it depends though. I mean, if p ends up being a fraction and you do 1 divided by 4 times a fraction, the math might end up working out where it comes out to a whole number. But more often than not, you're going to see it like a fraction when it's done too, after you plug it in. 4p is the focal width. That's what it's called. Which you can think of as kind of like a stretch. The focal width is the distance across the focus to the 2 points on the parabola. But it's kind of a long explanation. So that's the thing I didn't want to get into. Yeah? You would end up, yeah, it would be an equation of a parabola. So you'd have y equals some fraction x squared when you're done. Okay? Let's do a quick example. It's like I said, it's not as bad once you get into it. Oh, actually, before we do that, one more thing on here. If this has a distance of p, all right, what would be the coordinates of f?
Wait, from the V?
Yeah. Because remember, the vertex, for now anyway, is going to be 0, 0, always. Okay, until tomorrow, and we change it. But for today, 0, 0, always until tomorrow. Yeah. So the focus then is going to have the coordinates 0, p, right? Because it's still 0 on the x, but it has to go up p. And then the equation of the directrix. The directrix is this horizontal line underneath. Okay? What kind of equations do we have for horizontal lines? It's either x equals or y equals. They're y equals when they're horizontal. So if it's a distance of p down from the vertex, what's the equation of that line then? Yeah, y equals negative p. All right? Now, if this parabola were to open down instead of up, it would be positive p, and the focus would be negative p. All right? Because this is 0, and if this is a distance of p, then whatever this number is, this would be hitting the y-axis at that number, except negative. Right? Okay, so let's try one. So a parabola has vertex 0, 0 and focus 0, 3. What is its equation? Okay, so the vertex is 0, 0, focus is 0, 3. We want to make an equation of it. Okay, so before you do anything else, we need to figure out what's the value of p for this particular parabola. 3. Just 3, right? Because if the focus is at 0, 3, then this distance up to the focus would be 3, right? So p is 3. All right. Now, if p is 3, all I got to do is plug into that thing, right? So, what?
Is there any times where it's not
It's always with a 4. Yep. So this would be it then. The equation of that parabola is 1/12 x squared. Okay, so in practice, like I said, it's not so terrible. Okay, so I might have to have you go that direction with it, where I give you information about the parabola, i.e. like the vertex, focus, or directrix, something like that. Something that will allow you to figure out the value of p, and then you make the equation. Or I might just give you the equation, in which case you need to work it backwards and tell me where those other things are. Okay, so that's what we're going to try next, is I'm going to give you the equation of the parabola and ask you a whole bunch of information about it. See if you guys can come up with that. Okay, so let's say our equation of this parabola is -1/20 x squared. Okay, so what direction is this opening? Down. Okay, remember that. So find the coordinates of the focus, vertex, and the directrix. All right, so we're going to, well, I guess technically it would be coordinates of the focus and vertex, and then also find the directrix. Okay, so start with the easy one. Where's the vertex? 0, 0. Okay, easy enough. All right, so we got that. Now, this is a parabola that opens down. So the focus, is the focus above or below the vertex then? It would have to be below it. One way to remember that is a parabola always wraps around its focus. Opens up around the focus. So if it's opening down, the focus would also have to be down. Okay? All right, so the focus is down below the vertex. But how far below? 5. Okay? How do we get 5? Somebody raise your hand and tell us. Yeah.
You divide 20 by y equals -120 x squared by 4.
Mm-hmm. Okay. That 4 times p, remember that in the equation up above at the top? That 4p is the denominator of this fraction, right? So 4p needs to equal 20. If you have to write that out, no shame. It's fine.
So
4p has to equal 20 this time.
So, but 4 times p would equal
20.
Wouldn't that be? Well, but if we wanted to figure out the equation, that would help us. It'd be 4 times p equals. I'm not talking about the equation.
Oh, okay.
I'm talking about like the regular equation to find the distance.
It would always be 4p equals the denominator.
R equals the denominator.
Mm-hmm.
That's the bottom line.
Mm-hmm. Yep. So 4p equals 20. That means that the distance between the focus and vertex would have to be 5. Okay? And if the focus is below the vertex, what are the coordinates of that focus? 0, -5. Right. Yes, it would. Thank you. All right, 0, -5. All right, now, where's the directrix at? It's going to be up, right? Y equals 5. Yeah, good.
Wait, and it's -5. Like, this is
Yeah.
5 because it was -1.
It's -5 because we know the focus is below the vertex.
Why is it, but why would y equals 5?
Because that's above. This parabola opens down. So the focus is down here. The directrix is up here, positive. So directrix is positive, focus is negative. Yeah, it's the same distance but above it rather than below it. Yeah, sir.
For the 5,
Mm-hmm. That I took the 4p equals 20, divided each side by 4, so p is 5. Okay, so having a new definition for a parabola means that we can make parabolas go lots of different directions. So far, the only different ways that you guys have seen them have been up or down, right? Now we can make them go sideways. Oh, yeah. Oh, yeah. Now, it doesn't really change a whole lot about the equation, though, thankfully. But you can. You can make them go side to side, too. So let's try that. Nah. I'm going to make a handy-dandy little reference guide for you here, okay? So you can keep straight what equation goes with what direction it opens, okay? There's not a lot of difference between each one. So I'm just going to write down first the two that we just did. Okay, so if we have a parabola opening up, okay, focus is up here, directrix is down here. So this is the equation y equals 1 over 4p x squared. And yeah, vertex is right there. Okay, so we did that one. We also did ones that open down. So focus would be here, directrix would be up here. And that one was y equals negative 1 over 4p x squared. Okay, again, only difference, negative, because it's been flipped around. Now, our side-to-side ones, let's say it opens to the right. Then our focus is over here, and our directrix is going like this. Okay, so take a look. This is the only difference. Okay, take a look at the first one that I did and this one that I just did right now. It's the only difference between those two in the equation. The x and y swapped. That's it. Okay? If it opens left or right, it has a y squared in it. If it opens up and down, it has an x squared in it. That's it. Okay? Yes, sir? Yeah, exactly. Yeah. If it opens left, same thing as this one, but negative, right? Come on, who didn't see that coming? So focus is over there. There's the vertex. Directrix is now over here. And this is x equals negative 1 over 4p y squared. Okay? So up and down, x squared. Left and right, y squared. Just got to keep track of if it's positive or negative, depending on which way. But it makes intuitive sense. Okay? Opening up is positive. Opening down is negative. Opening to the right is positive. Opening left is negative. Okay? All right. So let's see if we can work with one of these new ones, the left or the right parabola. Okay? So a parabola, again, has vertex 0, 0, and directrix x equals 7. What is the equation? So now, the information that we're going to want to use for this is what's P, again, but also, based on the information, what direction does it open? Okay? And the equation of that directrix should tell you everything you need to know about which way it opens. Okay? The directrix I gave you is x equals positive 7. Look at your handy-dandy little chart up at the top. Where is there a directrix where x would be some positive number? when it's opening to the left. Take a look. It's not a y equals directrix. It's an x, i.e. vertical line, equals directrix. Okay? So it's got to be one of these two over here. All right? And which one of these has a directrix that's positive? Not this one. This one. Okay? It's going to open left. It's going to look like this. Okay? So we know it's got to open left. We know the equation has got to be some form of x equals negative 1 over 4p y squared. And then it's just a matter of what is p. Yes? Yep. Yep.
I was going to answer what P was.
Go for it.
Isn't it 7?
It's got to be 7. Right. If the vertex is 0, 0, the directrix is 7 over from there. So p is 7. And once you know all this information now, it's simple. It's 7. Because the negative's already taken care of right here in the equation. It's already there. So just take the 7, plug it in, and you're done. Okay? So we've got x equals negative 1 over 28 y squared. All right, so I got one more example for you, but before I do that, I want to justify for you guys just a little bit why we're doing what we're doing. Why in the world would we come up with another way to make a parabola equation if we already had a way to do it? Because math is stupid and we do stuff like that all the time? Oh, come on, you were supposed to nod your heads to that one. Anyway, no, it's because of this whole idea of focus, okay? So what does the word focus mean in general? Okay, so we usually think about it in terms of like when we're in class, we need to concentrate on something. So when they're saying, when your teacher says, hey you, focus, all right, what they mean is take all of your attention away from these other things and focus your attention on this one thing right here, whatever it is. Okay? So that's focus. So you're taking everything and focusing in it, moving it towards one spot. Okay? So a focus on a parabola, that's what it does. Anybody see those like little satellite dishes that are attached to homes? What shape do you suppose those are in? It's a parabola. Okay? Most people think it's a circle, but it's a parabola. So, if you see like a satellite dish from the side, it kind of looks like this. And there's always that little arm that sticks up and has that little thing attached to it, right? Guess what that is? It's the focus of the parabola. What?
Why we need a new equation?
I'm answering that question right now. Okay, so there's a little arm that comes out that's got this little thing attached to it on your satellite dish. What does that little thing do? Anybody know? It receives all the signals, okay? Well, why do we attach that thing to a parabolic dish? Why don't we just stick the little thing up next to the house without the dish? Yeah.
Because that little dish thingy
Yeah.
makes it so it's a wide, like a bigger area for signals to bounce.
Ah. So let's say we have a signal that's coming in like this.
Likely to hit it.
It's not even more likely, it will hit it.
Yeah, that it will.
What happens is, as the signal comes in, it bounces off the parabolic dish and boom, right in there. Maybe you have another signal that's coming in like this, boom, bounces off the dish.
No matter what, it goes to
Always goes to the focus. If you get another one that's coming in like this, bounce right in.
Bounces off the
If this thing is misplaced, you lose your TV signal. Because it's all focusing somewhere.
neighborhood and just turn them a little.
So if you walk around to your neighbors, you take the little arm and you go, just a little bit, TV's out. They can't get it anymore. Don't do that. Don't do that. Anyway, so, the point is that there are things, and it's not just TV antenna or satellites or whatever, or dishes. It's not just that, but there are lots of things that are made in a parabolic shape with a focus of some sort because of this idea how things can bounce off the dish and go towards the focus. So if we wanted to design one of these things and we were using our old way of making a parabola, would we know where the focus is? No. We would not know where the focus is, and we would not be able to pinpoint where that little arm is supposed to go and build one of these things. Okay? Yeah, kind of. All right, so I just wanted to give you guys, can you stop, please? Just wanted to give you guys one quick example of where this stuff is actually used. Okay, there's a point to figuring out where a focus is on a parabola. Now, are we all going to run out and design, dishes for your house? No, but there is application to what we're talking about, though, all the same. So, in any event. All right, so one last little example here, and then I'm going to have you guys jump into working in your journals for a little bit, practice some of this stuff. I just want to present it to you in a slightly different way, just so you're not thrown off later if you see this. So we're going to do the same kind of thing like we did on the other page. I'm going to give you an equation, but the equation is going to look a little different. So I want to identify the vertex, focus, directrix, and axis of symmetry. Haven't done that yet. For less talking, more writing, please. Negative 4x equals y squared. And then sketch a graph. All right, this is about the most I would ask you to do with this stuff, okay? So, we have an equation that is negative 4x equals y squared. How is the look of that different from all the rest of them that we've been doing? Okay, raise your hand so we get one thing at a time. So I had like 3 people talk. Levi, go ahead. The side that the x is on? Not necessarily, because if we go up here,
Y being squared now, isn't it?
okay, so it's kind of like one of these then, right? So what's different about like writing it this way versus writing it this way? Yeah. We do. It's just kind of hiding. You're on the right track, though. Yeah?
It's not a fraction.
It's not a fraction. Well, what should I do then to make it look like the other one so that it does?
Negative 4 over.
Negative 4 over... no, actually. Yeah, because look over here. It's x by itself, nothing multiplied by it, equals fraction times y squared, right? So there's an easy way to convert it to the way we want it to be on this one, right? You just have to divide each side by negative 4. So if we do that, then we're going to get negative 1/4 y squared. Now it looks a little more familiar. Okay? Well, I'm not done with the problem yet, but that's how I get the equation to look the way I want. Yeah. Yeah, and so in this case, remember 4p is the denominator of the fraction, right? So 4p would equal 4, so p is 1. All right, whatever is here, that's 4p. All right, so what direction does this parabola open? Raise your hand and tell me if you think you got it. Yeah. No.
No, I meant up. That's what I meant.
Yeah. Opens left. Okay, what 2 pieces of information in that equation tell me that it opens left? Yeah.
That it's x equals negative 1/4 p y squared. It's like y squared.
So what? Okay, you gave me more than I needed, but you're right. Okay, so either way you want to look at it, x is over here by itself, y is being squared. Either way, if you see that, it's a left-right parabola, one of the two. it's negative, so it has to be the left of the left-right type of parabola. Okay? So we know P is 1. We know based on how this is set up, it opens left. Okay, that much information, we can start to list off all this stuff we need now.
Would the vertex still be at the 0, 0?
Mm-hmm. Yep, exactly. We can start with that. Vertex is 0, 0. Okay, so if it opens to the left, where's the focus? He's got his hand up. Go for it. -1, 0. Yep. Okay, if it opens to the left, where's the directrix then? Yeah. At 1. Is it x equals 1 or y equals 1? X equals 1. Okay. All right, and then what is the line of symmetry for this parabola? Yeah. You're close, but not quite right. It is going to be one that looks like this, right? The line of symmetry is right here. That's not x equals 0. Y equals 0. It's the x-axis, right? But it's actually y equals 0. That's kind of a confusing fact for a lot of people, but it's true nonetheless. The x-axis has an equation, and the equation of the x-axis is y equals 0. Likewise, the y-axis has an equation, and its equation is x equals 0. Okay? So, all right. So our LOS, y equals 0. All right, and then it said sketch a graph, right? So we got to do that still too. So the graph of this thing, I'm just going to make it look like that fourth one up top there. So it's got to open to the right. Directrix is here. It should be at 1. Focus is at -1, 0. There's the vertex. X, Y. Good enough. Okay, so when I say sketch a graph of one of these things, the expectation is you have everything that I just put on it right there. Okay? Should see the focus, should see the vertex, should see the directrix, and I should see it opening the correct way. Alrighty? Alright, so we got about 25 minutes. We're going to jump into our journals and spend the rest of the time there today. Need to turn to page 37. Page 37. Oh. All right, guys, we are recording now. So I'm going to present you guys with a problem similar to what we did yesterday. But like I said, now we're going to take a look at what if that vertex is not at the origin anymore. So we're going to find the equation of the parabola. With vertex, wait for it, -1, 2, and focus. Oh, I meant +1, sorry. At 1, 2, and the focus is at 1, 5. Okay, so what I would do here is think about where these are on the graph. Some people can just do this in their head and they kind of see 1, 2, 1, 5, and they can place them. I have a hard time with that sometimes, so I like to just plot them real quick, okay? It doesn't have to be the prettiest graph in the world, okay? But just so you can tell by their placement where or what direction this parabola is opening, okay? So vertex is at 1, 2. So there's the vertex. And the focus is at 1, 5.
So that means it's facing up.
Very good. If the vertex is below the focus, this parabola has to open up around that focus, right? So we know the direction then, okay? And like I said, maybe you can do that much in your head. You can look at those two ordered pairs and figure it out, but I like to see it. So opens up, okay, which means we're going to be using this equation y equals 1 over 4p x squared somehow, okay? And what is the value of p for this particular parabola? Jason? It's not 5. It's not this time. Yeah, it's 3. Okay? And I see what you did. He took the pattern from yesterday and he said, oh, focus. I'm looking at that right there. It's a 5. That's my p, right? Because the vertex yesterday was at 0, 0. So you could do that with the focus, but you can't do that now, though. We have to figure out what's the difference between, so you have to count it. Another reason why drawing a graph wouldn't be a bad idea, because you can see it, right? You count up. From the vertex up to the focus, 1, 2, 3. So this distance in between those two, that's p, right? So it's got to be 3. All right. No, you're fine. I burned somebody's second hour on that same question. So, all right. So the equation then now is going to look like this. Y equals 1 over 12 x squared. The only difference now is our vertex is not at 0, 0. We have a translation, right? It's been moved to the right 1 and up 2. So if I'm going to take this equation and move it to the right 1 and up 2, how's it going to change? Levi. Mm-hmm.
Square plus 2.
Done.
That's finding the vertex, right?
Well, we know the vertex. We were trying to find the equation.
Yeah.
But since you brought it up, this is a equation in what form? This should look familiar. It's vertex form, right? What's the vertex? Look at the equation and just tell me what's the vertex. 1, 2, right? You guys remember doing that earlier this week? That's all it is. It's just vertex form. Okay?
We're trying to find the vertex equation to find that point, right?
No, we were just trying to find the equation of the parabola, and there it is. We're done. I gave you the vertex. You didn't need to find the vertex this time. You needed to find the equation of the parabola, which is this. And we'll do that in a minute. We'll go the other direction with it in just a minute. Yeah. Because it's a horizontal movement. It's always opposite, right? Mm-hmm. All right. So let me give you another one. Now this is for a parabola that opens up or down. Okay. So what if we did it with the left-right parabola? How might it change? There's a little sneaky part of this one that we need to talk about. So we'll do find the equation of the parabola with, let's do vertex -3, 5, and let's go directrix this time. So the directrix will be x equals 1. How about that? So the vertex, again, obviously not 0, 0, -3, 5 this time. And the directrix is x equals 1. Okay? I'm going to draw a little picture again, just because it helps me. So -3, 5. So -3 and then up 2, 3, 4, 5. So there's the vertex. And the directrix is x equals 1, so that would be over here, going this way. So what direction does this one open? To the left. Okay? parabolas open around the foci, or around a focus, and they open away from the directrix. So it's going to be something like this, yeah. Okay, that's that geometry we talked about yesterday. Okay, opens away from the directrix, around the focus. So we know it's going to open left. So what's going to be the equation we're going to be working with for ones that open left, Mr. Claypool?
One would be y equals.
Actually, it's x equals.
Oh, that's
That's what you meant.
Negative 1 over 16.
Oh, you already found the. Okay, I'm just going to go for p, but
Well, but
I don't want you to jump the gun just yet. Just hold on. I hear you. You were right, but okay. So that's the general equation we're going to start with, though, right? X equals negative 1 over 4p y squared. And what is p this time? 4, if you count it. We don't have the focus, but we have the directrix, and you can measure p to the directrix as well, right? So negative 3, 1, 1, 2, 3, 4. So p is 4. All right, so I'm going to do that first again. So p is 4, so now we've got x equals negative 1 over 16 y squared. And again, we have a translation to get it there. Yeah?
So when it times.
You want to take a stab at it?
Yeah.
Okay.
So the x equals negative 1 over 16, and then plus 3, and then square it, plus 5.
No. Okay.
Well, it was a
Hold on a second. I'm going to write down what he said, though, because I think a lot of you guys probably had that same answer in mind. So he said, but don't copy this down, okay? So he said, all right, so x equals negative 1 over 16, and then he did y plus 3 squared plus 5, right? She said?
Yeah, why is that not right?
Okay. That's not right because this is a y, not an x. So we have to flip-flop everything around. Okay? So think about it for a second. See if you guys can come up with it. What should that be? If this number in here has to be the y movement, what do you suppose it's going to be? Y minus 5. Just hold on. And then what goes on the end of it then?
No, minus 3.
It's a minus 3.
Because, guys, hold on.
Okay.
No, guys, listen.
Time out. Listen to Claypool. He's got something.
Because in the parentheses, everything's changed, but on the outside, it doesn't change. That would make sense.
That's
makes
it.
Perfect sense.
That's it. Right. On the inside, it's always the opposite. But on the outside, it always stays the same. Okay? I know it's weird because we always talked vertical stays the same. Horizontal, opposite. Well, when the variables have switched positions, those rules switch too. Okay? So if you just remember what he said, anything on the inside is going to be opposite. Whether it's x or y, it's opposite. And whatever you're putting on the end of it is going to be the same. In this case, y is in the middle, x is on the end. Okay? Sorry. But it works, though.
We say we understand, but as soon as we do one question, we're like, what?
No, I understand it. No, I do too.
Sure you do. I guess maybe it's homework.
All right, so let's see how well we understand it. So what I'm going to do is I'm going to give you an equation of a parabola that opens to the right, and we're going to see if you guys can tell me where the focus, vertex, all that business is. We're going to take this process backwards, but I'm going to give you a right opening parabola to do it. Okay? So we're really going to test and see where we're at with this. So x equals, oh, by the way, yeah, that was it. X equals, let's do 1/12 y minus 1 squared minus 5. And let's see if we can figure out vertex, focus, directrix, and just for the heck of it, let's get the line of symmetry up there too. All right, so I'm going to give you guys a little bit of time to try it. We'll come back and talk about it as a class before we're done. But take like 5 minutes or so and see what you can come up with. See if you can follow the logic we talked about in the last problem and then work it backwards.
Once you found P, you gotta, since it's going right, you gotta go on the x-axis.
So it'd be 1, 3?
Negative 2. No, negative 2, 1.
No, it's still turning right. It's gotta be positive, it's turning. Wow,
You guys are on the right track there. Draw yourself a picture. Draw yourself a picture. It'll help.
Okay, but then how do you find the direction?
It helped me if I drew a picture. Like,
I drew the vertex and stuff, but I don't know which way it's pointing.
you know how it's 1 over 12?
Yeah?
So if you do 12 divided by 4, that gives you 3.
Oh, so that's the same.
So go 3 back would be your direction. So negative 8. You know what I'm saying?
Okay, so do I go like this? So here's my graph. Right here. I go back.
You go back 5.
So this way 5?
Yeah, your vertex is back 5, so you want to go back 3 more to find your direction.
No, no, this one.
To find your direction. And then you go 3, Megan. Then you go 3 the other way to find your, it's confusing.
All right, you guys want me to show you what I got here?
Yeah.
All right. Again, I mentioned this to several people. When in doubt, draw yourself a picture, especially when with these that move. It's so much easier if you can take a look at a picture. So there's my picture. P is equal to 3 because it's 12 on the bottom of that fraction. Now the vertex, remember, this one stays the same, this one changes sign, right? Negative 5, 1. If you don't have that starting point, everything else falls apart. Okay? But it's negative 5, 1 is your vertex. Now on your graph, as soon as you have the vertex put on your graph in the right spot, and you know which way it opens, right? Opens to the right. Then you can start to count towards the focus and count towards the directrix. From the vertex, I'm going to have to move to the right to get the focus 3. So that's at negative 2 then. So negative 2, 1 is the focus. Directrix, I have to go back 3. That's over at negative 8. And it's a vertical line at negative 8. So x equals negative 8. And then the line of symmetry, right down the middle of this thing, that's y equals 1.
If I ace the quiz right now in this section,
We don't have a quiz on this, though. There's a test that's got it on it, though. Yeah.
How did you figure out that
Directrix. All right. I know P is 3, and the directrix is always on the opposite side of the parabola, like away from the parabola. So I got to go left to get to the directrix. Yeah, exactly. That's negative 8. So.
wait, so that's all we're learning today?
Yep. And then you're going to work on some homework after we're done talking here. Yep. Most got close. I don't know if anybody actually finished the whole thing. All right. So ready to do this stuff? All right. All right. Let me stop my camera, and then we can get started.